So on today's tutorial, we are going to use this amazing Python library, which is called diffusers, in order to create an emotion recognition synthetic dataset. We are going to use Stable Diffusion and we're going to generate hundreds or thousands of images, and then I'm going to show you how to use this dataset in order to train an emotion recognition model. In a future tutorial, I'm going to show you how to use this dataset in order to train a model. So this project is going to be amazing, and we're going to get more familiar with diffusers with this library from Hugging Face, and we're also going to get more familiar with image generation, Stable Diffusion, and most importantly, we are going to get more familiar with synthetic datasets and with how to create a synthetic dataset. Today's tutorial is not for beginners. Oh no, creating a synthetic dataset is a very advanced skill and is definitely going to set you apart from many other developers and many other machine learning engineers. So this is a very advanced technique in machine learning, and let me show you how we are going to create this synthetic dataset. So this is a notebook I created in my Google Colab, and this is where we will be working today. I'm going to work on a Google Colab only because we have a free GPU, and only because it's going to make things easier for you to reproduce all these results. But you can also work on your local computer. If you prefer, you can work on something like PyCharm or Visual Studio, and it's going to be pretty much the same. So you can just work wherever you want. But in my case, I'm going to show you how to do it in a Google Colab. So this is a notebook I have created in my Google Colab, and we are going to execute these two cells. First, this is where we are going to install all the requirements we need in order to work on this project. This is where we're going to install diffusers, which is this library over here, and we also need to install transformers, which is another library we need in order to work on this tutorial. And then I'm also going to execute this cell over here, which is where we are going to create an object, which is the object we are going to use in order to do all the image generation. This is how we are going to use Stable Diffusion using this library over here, right? So I'm just going to execute these two cells first, and then I'm going to show you how to do all the image generation. So the only thing I'm going to do is to execute these two cells. Okay, now it's ready, and if I scroll up, let me show you something. You can see that we have downloaded many models and many files once we executed these two instructions over here, and these models are needed in order to use Stable Diffusion and this library over here, which is called diffusers. So please mind that once you execute these instructions, you are going to download many files, and some of them are huge. Like this one over here is 3.4 gigabytes. Then this one over here is 1.2 gigabytes. So if you are working on your local computer, please mind that these instructions are going to download many files, and some of these files are huge. Now let's continue. But before we continue, please remember that we are going to work on a Google Colab with GPU, right? So to make sure you are working on an instance with GPU, you need to click here and then change runtime type, and you can see it says T4 GPU, right? Please make sure this option is selected over here, otherwise you are going to be executing everything on a CPU, and it's just going to make everything takes much longer, right? It's going to make everything to take much more time, so it doesn't make any sense whatsoever. Please make sure you are working on a GPU. Now let's continue. And now let me show you how to do the image generation. So you can see that these are only a few instructions, and this is everything we need in order to do the image generation. You can see I'm importing matplotlib, and this is the library we are going to use in order to visualize the images we are going to generate. And I have defined two variables. One of them is called prompt, and the other one is called negative prompt. And then the only thing I'm doing is calling this object we defined over here, which is called pipeline. And then the only thing we need to do is to input the prompt and the negative prompt as arguments into this function, and that's pretty much all. That's all it takes to do image generation using this library, which is called diffusers. This is amazing. This is very simple, very straightforward. And now let me show you exactly what these two variables over here mean. So prompt, this is where we are going to specify what's the object we are going to generate, right? So this is going to specify what's the object or what's what's the image we are going to generate. And then the negative prompt, and this is very important because this is where we are going to specify all the objects we don't want to generate. And Stable Diffusion is going to try to stay away from everything that's over here. And this is a very standard negative prompt. If you search for examples on Google, you are going to see that this is how they usually look like. In this case, remember, we are going to generate human faces, we're going to generate people, and we want these faces, these people, to look as realistic as possible, obviously. Otherwise, this synthetic dataset doesn't make any sense whatsoever, because once we train a model in order to recognize different emotions, we are going to apply this model on people, on real people. So the faces, the people we are going to generate now are obviously going to look as realistic as possible, otherwise nothing is going to work. So we're going to tell Stable Diffusion to stay away of everything that looks like a cartoon, like an anime, like a sketch, and this is going to help us in order to achieve much more realistic results. Also, we are going to try to generate images with the highest resolution and the highest quality as possible, so we are going to tell Stable Diffusion to stay away of everything that's low quality, everything that's low resolution, and so on, right? We are going to try to generate images in VGR, we are going to try to generate color images, so we are also going to try to make Stable Diffusion to stay away of everything that's grayscale or everything that's black and white. And something which is usually a problem when dealing with person generation, with people generation, with face generation, is that sometimes the results look a little disfigured, right? The people look a little like disfigured or deformed or something like that. So we are going to explicitly tell Stable Diffusion to generate results which are very far away from these objects over here, which are disfigured and deformed. And this is going to help us in order to generate pictures with people which do not look disfigured or deformed. This is very important. So this is a very classical negative prompt when dealing with person generation, and this is the one we are going to use now. So in order to move one step at a time, let me show you how it works. So I'm going to input a prompt which says something like, let's start one step at a time. So I'm going to say something like a picture of a squirrel, right? So we're going to generate people later on, we're going to generate human faces, but let's take it one step at a time. So I'm going to generate a picture of a squirrel, and this is going to be my negative prompt, and let's see what happens. Oh, I see I have this character over here, which is not correct. Okay, so this is going to take some time, and now the image is being generated, and then we are going to see how it looks like. So this is very important. You can see it takes 9 seconds in order to generate this image, and this is the result. And you can see that this is definitely a picture of a squirrel, and this doesn't look like a cartoon, doesn't look like an anime, doesn't look like a sketch or anything like that, and this is like a very high resolution image, right? So now let's do something which is going to be more similar to the images we are going to generate in this tutorial, which is a human face, right? Yeah, let's say something like this. Okay, this is the result. You can see that the eyes look like a little disfigured, or the eyes look like a little strange, but other than that, I will say this is definitely a human face, so everything is okay. Now let me show you the prompt we are going to use in order to generate our results. This is the prompt we are going to use, and this prompt is going to help us in order to achieve the best quality results as well. So you can see, I'm going to try to make it look better, something like this. Okay, something like that, and maybe I can do it even better. I can take these two words over here, and this is going to be better. Okay, and later on I'm going to explain why we have these characters over here, but for now the only thing I'm going to do is to replace these characters with a man smiling. Okay, so it says medium shot portrait of a man smiling, front view, looking at the camera, color photography, and then it says photorealistic, hyperrealistic, realistic, and so on. So we are going to use this prompt so we make sure we help Stable Diffusion to make images which look realistic, hyper-realistic, with many details. We want these pictures to look as realistic as possible, and we are going to tell Stable Diffusion to create an image of a man smiling and with a front view looking at the camera and so on. And also this is going to help Stable Diffusion to make color images, right? Ideally, we want to generate color images and we want to avoid anything that looks like grayscale, right? So let's see what happens if we use this prompt. Okay, and this is the result. You can see we have generated a picture of a man smiling, which is looking at the camera with a very frontal view. This is a color image, so everything is perfect. Now, let's do something else. I'm going to repeat the same process 10 times for j in range 10. And I'm going to do exactly the same. I'm going to use the same prompt and the same negative prompt every time, and we're just going to plot all the images, and this is going to help us to look at many different examples so I can show you something. And these are the results. So you can see that we are generating images which definitely look realistic. They definitely look very well, very realistic. Most of these pictures, if not all of them, are looking at the camera. They are frontal view. In most cases, this is not really frontal. This one over here is not frontal either. This one is not frontal either. I mean, it's like in on the side, a little on the side, but they are pretty well. Now, something that you are going to notice when you are generating your images is that in some cases, although we are specifying exactly what we are looking for over here, and we are specifying in Stable Diffusion exactly what to stay away from, in some cases we are going to have some results which don't really match exactly what we have over here, right? This is going to tell Stable Diffusion to try to generate something like this, but in some cases it's not going to be possible, and we are going to have some images which are not really frontal, or we are going to have some images which are not really color. I mean, some images which are going to be grayscale. I mean, we are going to have some situations which are not going to be exactly like this as we have specified over here, but in most cases we are going to have some very meaningful results. In most cases we are going to have some very good results. Now, something that I noticed looking at these images is that I think Stable Diffusion is taking this parameter we have over here, which is color photography. It's taking this as a parameter to specify the skin tone of the person that's being generated, right? If you look at the results, most of these results are from a person with a dark skin tone. So we are going to do something. Remember, we are going to generate an emotion recognition dataset, and we are going to generate a dataset which is going to be comprised of many images of people, of faces, human faces, and we want to make this dataset as diverse as possible. So we are going to do something. We are going to explicitly tell Stable Diffusion what's the ethnicity we want to generate in all these pictures, and we are going to generate pictures of people from many different ethnicities, and we are going to have the same amount of all of these ethnicities, so we make sure this is a very balanced dataset and this is a very diverse dataset, and that we can use this dataset in order to train a model. So we are going to do something. Only to show you how it works, I'm going to say medium shot portrait of a white man smiling front view and everything else, right? Now I am explicitly telling Stable Diffusion to give me pictures of a given ethnicity, and let's see what happens. And these are the results. You can see that now we are generating images of people with the exact ethnicity we were asking for. And this is what I meant regarding that. Although we are specifying Stable Diffusion that we want to generate color images, we want to generate images in BGR, we want to stay away of everything that looks like a grayscale image, every once in a while we are going to generate images like this, right? I'm not sure if this is like grayscale or this is like something which looks like grayscale, but this is not the type of images we are looking for, but nevertheless we are going to generate images like this every once in a while. But other than that, all the other pictures look pretty much perfect. This is not really a frontal view, but this he's looking at the side, but other than that everything is okay. We have another grayscale image over here, and this one is not looking at the front either. He's not looking at the camera either, but everything is okay, right? Most of the pictures are okay. So this is exactly what we will be doing. This is exactly how we are going to generate all these pictures in order to make sure, in order to try to have a very diverse data set of people with many different ethnicities and many different features and many different everything. In order to keep this data set as diverse as possible, we are going to explicitly tell Stable Diffusion what are the ethnicities we want to generate, and we also want to tell Stable Diffusion the gender we want to generate. We want to generate many pictures of men, and we also want to generate many pictures of women, right? So this is how we are going to do. I'm going to create another variable which is ethnicities, and this is going to be something like this. Let's start with Latino, then white, black, Middle Eastern, Indian, and Asian. So these are the 6 ethnicities we are going to use in this example in order to show you how to create this synthetic dataset. And now let's continue. I'm going to create another list which is genders, and this is going to be male and female. Okay, so male and female, and we also have these ethnicities and everything is okay. And now I am going to replace this value where it says white. Maybe I can do something like this. Latino, white, black, Middle Eastern, and Indian, and Asian. So I can just replace all these 2 words. And then I am going to say format, and I am going to do something like, I'm going to do it over here. I'm going to import random because we are going to sort for every single iteration. We are going to sort one of these ethnicities and one of these genders. So ethnicity equal to random choice ethnicities. Okay, and then gender equal to the same random choice genders. Okay, and then I'm going to put this value over here, and then I need to do the same over here. Okay, now the results are going to be more random, right? Now we're going to generate pictures of people of many different ethnicities and many different genders, or actually 2 different genders. So let me show you how the results look like in this case. And these are the results. So you can see in this case we're generating the picture of a woman, so everything is okay. Then we're generating the picture of another woman, everything is okay. And then we are generating the picture of something which is definitely not a person. So let's see what happens over here. But let's see if we have another result like this. This is another picture of a person, a person, a person, a person, and a person, a person, and also a person. So this is the only strange result we have over here. And I'm not sure why this is going on. My thoughts are that as we are specifying the gender as male or female, and we are not really explicitly telling Stable Diffusion to generate people, so I guess in this case it has generated something which is not a person, right? It's some sort of animal or something like that. So let's make sure we are generating people, and maybe we can say something like this: man and woman. Right? You can see that this is not a set and forget, right? This is something you have to be on top to make sure everything works as expected. Okay, and now we have another situation over here, and if I scroll down, we generated a couple of animals over here. Not sure what could be going on, but I am going to do something. I'm going to explicitly tell Stable Diffusion to generate pictures of people. So medium shot portrait of a person. I'm going to do it like this again. And I'm going to remove the A over here. Or maybe I can do it like this. Okay, now we are telling Stable Diffusion to generate pictures of people, and let's see if this fixes all these issues we are having. Okay, now we are making some progress because now we are generating pictures of people. We are not generating any animal whatsoever. All of these pictures are about people. But I do notice that this random is not really that random, right? Because we are generating pictures of women in all cases. And also I see the ethnicity is not really that diverse. So let's do something. I'm going to start this random generator. I'm going to say random seed 50 maybe. I'm going to do something which is I'm going to print the ethnicity and the gender we are using. Everything's okay, right? Yes, let's see what happens. Okay, we obviously have a mistake because you can see that we are not generating the pictures we are looking for, right? We have definitely a mistake. So let me see what could be going on. Okay, I see the issue. So the format, this is actually only one string, but the format we need to do it in this one over here. Okay, over there. Okay, now this is going to work just fine. Okay, now everything seems to be just fine. Here we are generating a Middle Eastern female and everything looks okay. Black male, Asian female, black male, Indian female, white male, white female, and so on. Okay, now everything looks the way it should. Everything looks much more diverse, so everything is okay. So I'm going to do something, because I notice in these two cases we are generating the picture of an entire person and we don't really care about the entire person. We only want a portrait, right? So I'm going to do something. I'm going to get back to the original version, which was this one. And then I'm going to remove the seed because, well, we don't really need it. And then that's pretty much all. And now let me show you how to generate all the different emotions. Remember, this is an emotion recognition dataset, so it's very important we generate different emotions. And the emotions we are going to generate are happy, sad, surprised, and angry. Let's keep it simple for now, and we are only going to generate these 4 emotions. Some of these emotions are going to be easier than others in order to generate an image of them. For example, if we want to generate happy pictures, the only thing we need to specify is smiling, and you can see that all of these pictures are smiling, and these are definitely very happy people. So this is all we need in order to generate the happy emotion. But if we want to generate the other emotions, we need to be a little more crafty, because otherwise the emotions are not going to be very realistic. So let me show you. So in order to generate the happy emotion, by saying smiling is going to be enough. And if we want to generate angry people, the angry emotion, I think it's going to be just fine if we just set it as angry. Let me show you. I'm going to generate 3 pictures. And this is what we got. I will say that we are okay. I mean, yeah, I will say these pictures are angry. Maybe they are not super angry, but they are angry. I mean, it's okay. So the happy emotion is going to be very easy. The only thing we're going to do is to put smiling. In order to do the angry emotion, we're going to just say angry. But in order to generate the other emotions, which are surprised and sad, we are going to use these prompts we have over here, right? For example, for surprise, we are going to say surprised, open mouth, and raised eyebrows, right? So not only we are going to say the emotion, but we're also going to describe how this emotion looks like on a face. And we are going to do the same for the sad emotion. We're going to generate people frowning and with a sad face expression and crying, right? And this is definitely going to be sad. So what I'm going to do now is to create a dictionary. Emotions is actually going to be a dictionary, and we are going to use this dictionary in order to say all the prompts we are going to use in this case. This is going to be something like emotions prompts, something like this, emotion prompts. So happy will be smiling, sad will be this prompt over here, let's do something like this. Okay, surprised will be this prompt, and then angry will be angry. Okay, so this is pretty much all. And obviously we want to create a data set, and remember, data sets always need to be balanced, right? Somehow balanced. So we are going to generate the same amount of pictures for each one of these emotions, and this is how we're going to do. We are going to do something like this for emotion prompt in emotion prompts, then something like this, and then format emotion prompt. Sorry, this is going to be emotion prompts keys, and then emotion prompt. This is actually emotion. This is emotion prompts emotion. Okay, this is going to work just fine. Now for every iteration we are going to generate a picture for each one of our emotions, right? So now I'm going to print emotion, ethnicity and gender, and let's see what happens. And I'm only going to do it for one iteration, right? Or for 2 iterations. So let's see what happens. Okay, here we have happy, an Asian female, and yeah, everything's okay. Sad, a Latino male, everything's okay. Yeah, he looks sad. Surprised, she looks surprised for sure. Here we have angry, and we also have a man which is pretty much naked. I don't know how that happened, but it doesn't matter. We only care about the emotion, so everything's okay. Then let's continue. This one is happy. This one is sad, this one is surprised, and this one is angry, and yeah, he looks angry for sure. So these are the pictures we are generating, and we are almost there, because now the only thing we need to do is to iterate in something like 250 times. We're going to iterate 250 times, and this is going to generate 1,000 images, and that's going to be pretty much enough in order to train the emotion recognition model we want to train in a future tutorial. So now the only thing we need to do is to iterate all these many times, and then we are going to save the pictures in this colab, and then we are going to get the pictures into our computer. So let's do something. I'm going to create some directories. I'm going to import OS, and then I'm going to OS, make dirs. This is going to be content, faces, happy. Let's do something exists. Okay. Something like this. I don't remember if it's exist. Yeah, exist. Okay. And this is going to be true. And we're going to create a directory for each one of our emotions. So sad, angry, and surprised. Okay, so now we're going to create we're creating a directory for each one of our emotions, and then the only thing we need to do is to save the pictures there. And something which I haven't told you so far is that the object we got, this image we got when we execute this instruction, is a pillow image, right? So this is in pillow format, and this is a pillow object. So in order to save this picture, we need to say something like this: image save. And we need to specify the location, and this is going to be something like this. Format emotion, and that's pretty much all. And then obviously We are iterating over here. Okay, so we are going to save the pictures in this directory, and we are naming these pictures according to the iteration we are currently in, and we are just filling the number, the file name with 4 zeros, so we make sure all these file names are named properly. So this is pretty much all we need to do. We don't really need to visualize the pictures anymore. We don't really need to do this print anymore, and although we are going to run this process for 250 iterations, so we generate 1000 pictures, let's do it for only maybe 2 or 3 iterations for now, so we make sure everything works properly, and then we are going to run this process for 250 iterations. Let's make sure the pictures are saved properly, and also let's make sure we can get these pictures into our computer, right? Because remember, we are working on a Google Colab, so we need to do something in order to get the pictures into our computer. So let's execute it and let's see if it works. Okay, so this is what we got. Remember, we are not visualizing the images anymore, so this is the only thing we got now. Now, please mind this message we got over here, which says potential non-suitable for work content was detected in one or more images. A black image will be returned instead. So you are going to have a similar message every once in a while, and this means that after you generate the entire dataset, you will need to curate this dataset, and you will need to remove all these black images which have been generated. Now I'm going to show you how to get all these images we generated, and then we are going to do the entire iteration, right? Then we are going to iterate 250 times, and we are going to generate 1000 images. So let me show you how to get these images first. I have a few commands over here. The only thing I'm going to do is to copy and paste these commands. This command over here is going to zip the entire faces directory we created with all the pictures within this directory, and then we are just going to generate this file which is called faces.zip. So I'm going to execute this file first, and then we are going to mount our Google Drive, because we are going to copy all this data into our Google Drive, and then we're just going to download the file from our Google Drive, and that's going to make the process of downloading this data much easier. Okay, and then the only thing we need to do is to execute this command over here. And you can see that it says scp this file, which is faces.zip, into this location of my Google Drive, which is my drive, synthetic data, face generation, stable diffusion, faces1.zip. Actually, I can call this file faces.zip. And if I show you this location in my Google Drive, this is a directory I created in my Google Drive, which is called synthetic dataset face generation stable diffusion. So please remember to change this value to a directory in your Google Drive, otherwise this is not going to work. So the only thing I'm going to do is to press enter, and this is going to take care of copying this file. Let's see what happens. I think this directory, I have a typo with this directory name. Yeah, I have a typo. Synthetic dataset face generation stable diffusion faces.zip. Let's see now. Now everything's okay. And if I get back to my Google Drive, if I refresh, sometimes you have to wait a few minutes. Okay, now. So I'm going to take this file and I'm going to download this file like this. Now I'm going to open this file, and this is where we have these 4 directories which are surprised, sad, happy, and angry. And let me show you a couple of examples. This is one of the images under the surprised category. Now let me show you another example over here. This is sad, so everything is okay. Happy, we have a person that's smiling, so everything is okay. And then angry, this is the black image we generated, so we are going to remove this image later on. And this is a picture of a person that's angry. So everything looks okay. So the only thing we need to do now is to iterate for something like 250 iterations. So we are going to generate 1000 pictures, and then we are just going to do the same process. We are going to zip the directory, and then we're just going to download the directory like this. Now I'm going to scroll up, and I'm going to generate something like 1000 images, and that's pretty much all. So something that's very important is that if you want to download exactly the same dataset I am currently generating, this is going to be available in my Patreon, so it's going to be available to all my Patreon supporters. If you want to download exactly the same dataset I am generating right now, you can definitely do so in my Patreon. So this is going to be all for today. This is how you can generate an emotion recognition synthetic dataset, and this is going to be all for this tutorial. My name is Felipe, I'm a computer vision engineer, and see you on my next video.